All right, this is your video answer key for your Math 6 test that you just got back. Make sure you have the following things in front of you. Your test, obviously, since we're going over it, make sure you have yours. Something to write with to kind of make corrections as we're going. And your test corrections sheet. Just a reminder, you need to make sure you do that. You need to correct the problems you missed later. That'll be due soon. So go ahead and make sure you've got that as well. Sometimes students even work on that while they're watching the video and they pause and they go to their sheet and they fill it out for a minute or two and then they come back. So you want to think about doing that as we go here. That being said, let's go ahead and jump right in. In this first learning target here, you were to solve each equation. Show your work. Well, the reminders, hopefully you remembered these things. One, we want to get the variable by itself. Okay, in each of these problems, something is happening to it. We want to isolate the variable first. And the way we do that is by using inverse operations. Okay, those are the opposite operation. And then we want to make sure we can check our solutions. So in this first one up here, if we want to get the g by itself, it ends up having a value of 5 because we want to add 3 to both sides. That isolates our variable now. It's by itself. There's your solution. You can check it by plugging it back in to making sure that that would actually equal 2, and it does. In the second one, you want to get rid of adding a half. So if we subtract a half from both sides, well, then we've isolated our variable, but we still need to do some fraction work. 7/8 minus a half, well, let's make them compatible. So that ends up being 3/8. All right, your y value is 3/8. 3/8 plus a half is 7/8. In the third one, you want to remember this is really division. The way we get rid of dividing the variable by 16 is we multiply both sides by 16 right there. That will cancel out. You still have your variable though on the left side, and over here you would get 8. All right, so 8 over 16 is really the same as 5/10 or a half. That's true. This last one here, x has a value of 4. All right, check your work there, make sure it's good. Number 5 was the same kind of thinking, but taking it one step further. If b minus 10 is 5, let's do that first before we go on. Let's get rid of the minusing 10. Okay, so add 10 to both sides. Now we've isolated our variable. We then plug it into the second part of the problem. What is the value of b plus 6? Well, we already know b is 15. So what is the value of 15 plus 6? 21. There's your solution. We had to prove it. Showing our work is good. Using words is good. Drawing pictures is good, as long as it supports your answer. All right, lots of ways to show that. In 6 and 7, we had to decide which of these equations best represent each situation. Now, there were 6 equations to pick from. They all involved a variable, a 2, and a 10. So there's lots of different groupings of this. So we had to read these scenarios and figure out which one of these up here supports that problem or shows what's going on in that problem. So number 6, Clara ran the same distance 2 days last week, totaling 10 miles overall. How many miles did she run each day? So here's your 2. She ran the same distance 2 days. We don't know what she ran though. So we want to think of this one with this kind of approach. She ran 2 days a certain distance each day, and if we multiply that by 2, it would equal what she ran total. Okay, so there's kind of a hint for your equal sign. It will equal 10. So she ran 2 days, a certain number of miles, it's 10 total. Now you could even figure this out and say, I know she ran 5 miles each day, and that would be true. In number 7, after Lou poured 2 liters of water into a large jug, the jug then contained 10 liters of water. So after he pours 2 liters in, there's 10 liters in there then. So there was something in it before. That's what you had to kind of realize. There was something in it. He added 2 more liters. He ended up with 10. Well, if I show that mathematically, that was this one. Something plus 2 will equal 10. And that one was right up there. That was that one. Okay. That shows this scenario because it had some water in it. He added 2 more and it resulted in 10 liters total. So that was that one, not any of the others. In number 8, Sophia is buying party favors. She has a budget of $2.50 per person and is planning on spending $75 total. Write and solve an equation to find how many people, there's a variable, how many people she can invite to her party. Well, there's a lot of ways to figure this one out. She had to use the 75, the 250, and the variable. You could have done some division to figure out the variable. You could have done some multiplication, including the variable. There's more division there, but you had to group these in a way that supported the problem. So lots of answers could work for that. But if you solve it, which you were supposed to do also, write and solve, you would have found out that she can invite 30 people. Because if I solve any of these, 30 would be what makes the problem true now. In the next one, number 9, a repairman charges $20 for coming to a home for a service call and $40 an hour for the service. Write an expression to represent her earnings for H hours. So we don't have all the information, but we basically can show how we would figure out how much we would pay the repairman, okay? We know we got to pay $20 just because they came to our house. Welcome to the real world. And we know we also got to pay them $40 an hour. But Mr. Herndon, we don't know how many hours. You're right. So we show that by just using the variable. 40 times the number of hours. Okay, this is how we would figure out how much we pay them. If they came for 1 hour, well, it's 20 plus 40 times 1. If they were there for 3 hours, it's 20 plus 40 times 3. Okay, we can use this to figure out what we should pay them. But you had to show something that was equivalent to that. Numbers 10 and 11, we got into the inequalities section at this point. So write an inequality for each sentence. Well, number 10, swim practice will be at least 40 laps. Well, that means that the number of laps is going to be at least 40. So we want to use the greater than or equal to sign. Okay, this can be any number that's more than 40 or equal to 40. So that shows this situation right here. It could be 50 laps. It could be 41 laps. It could be 1,000 laps. That would be painful. Or it could even just be 40 laps. Okay, we just know it won't be less. Number 11, the mountain is less than 14,000 feet. So the mountain height is unknown. That's our variable. But we know it's less than 14,000 feet. So something, our variable, is less than 14,000. Okay, this could be a whole bunch of numbers, anything less than 14,000. But that's how we show it with an inequality. In number 12 and 13, we were supposed to solve the inequality first and then graph it. Well, by solving it, we do the same thing we did earlier in the first 4 problems. We want to isolate our variable and solve the inequality. So if I want to get rid of that minusing 6, I have to add 6 to both sides. That will give me the variable all by itself now. And if I, on the other side, add 6, that's where the 9 came from. So we've gotten rid of that minus 6 by adding 6 to both sides. We end up with this, and that is our inequality. Okay, that is what we now want to graph. H is greater than or equal to 9. So on our number line, we number it up, and we put a closed dot on 9. And we want our solution set to be everything that is greater than that as well. What we were looking for was the right dot in the right spot, going the right direction. So that's the first one. Number 13, d divided by 3 is less than 2. Well, if you want to get the variable by itself, you have to get rid of dividing by 3. So we multiply both sides by 3. That cancels that out. That ends up with a 6. So we really have d is less than 6. And that's what we want to graph. We want to number our number line again. I put 6 in the middle, just count it up, count it down. And I want an open dot this time on 6. We use an open dot because it's that symbol. When it's less than or when it's greater than, we use an open dot. When there's an equal part to our symbol, we use a closed dot. So this is an open dot on 6, and we want every number that's less than it. All these values that are less than 6, well, that's 5, 4, 3, and so on. That's what that one would be. Number 14, Tasha can spend no more than $50 on new boots. You had to write on an inequality to show how much she can spend. Then you had to graph the solution on a number line. Well, if she can spend no more than 50 bucks, we write this. The amount of money she can spend needs to be less than or equal to 50, okay? Because she can really spend up to 50 bucks. She just can't spend over that amount. So once I've done this, now I graph it. And that will be a closed dot on 50. And any amount that she can spend is going to be less than that. So it can be everything going left on our number line. It can be 40 or 30 or 20 or whatever, okay? Lots of options. Number 15, the high school soccer team can have no more than 26 players. Write and solve an inequality to determine how many players can make the team if the coach already has 17 players. Then interpret the solution. So what's going on here is that they can have no more than 26 players, but they've already got a few spots filled. So we want to show this. They already have 17 players. They can add a few more to their team, but whatever they add needs to make sure that we are still less than or equal to 26 because of that statement right there. They can have no more than 26. So this is our inequality. If we solve that by getting rid of the plus 17, we end up with this. Okay, this tells us really they can add up to 9 more players. So that's the solution to our inequality, how many players they can still really add to their team if they want. The interpretation is just where we use our words to summarize what we're finding out now. So I wrote this, no more than 9 players can make the team. Okay, something that is the same as that is acceptable. No more than 9 players can still be added to the team. Let's keep going here. Number 16 and 17 and 18 and 19 all go together. You need to understand that he receives $3 for weekly allowance, and he also gets $1.50 for each chore he completes. So number 16, there's a couple ways to show our equation here. Okay, his total earnings, that's T, that's determined by his weekly allowance plus $1.50 times the chores. Okay, if he did 1 chore, it's $1.50 times 1. If he did 5 chores, it's $1.50 times 5, whatever. So this is one equation. Another one that also kind of works because they don't necessarily tell you here if you should add the 3 or not. You could have just maybe shown this. Okay, I would accept that as well. Number 17, complete the table below to show the relationship number of chores and the total amount earned in 1 week if he earns his allowance and he completes some chores. So you number your chores, 1, 2, and 3, and if he did that amount of chores, there's your earnings. And you can see underneath it, he gets his $3 plus $1.50. He gets his $3 plus $1.50 twice. He gets his $3 for allowance plus $4.50. You know, that's a chore 3 times, really. So this is the amounts that we've solved. We then graph those on the graph, okay? So you should have your coordinates there for 1 chore, 2 chores, and 3 chores. And the last question here, how much will he make if he gets his allowance? Well, that's $3. And he completes 5 chores this week. Well, 5 chores at $1.50 each would be $7.50. So if I combine those, he gets over $10. Okay, he gets $10.50. That is the end of that section. Let's go to the final problem here, the log ride. They give you a bunch of information up here. How many people can go on it, the weight limit, the average adult weight, kid weight, whatever. Let's just jump right to the answers here. Number 20, why does the inequality above use the less than or equal to symbol? And the reason is because the weight of the log ride can't be more than 1,500 pounds, all right? That is the maximum weight, and that's what it tells you right here. It has a weight limit of 1,500 pounds. So everything on it needs to add up to a weight that is no more than 1,500, okay? They want you to explain what each of these things represents in the problem. Well, the 150, that's the average weight of an adult. Okay, according to this situation, that's what that was. The 100 was the average weight of a child. The 200 was the weight of the log itself. The 1,500 was the maximum weight allowed for safety reasons. A in this inequality right here represents the number of adults, and C represents the number of children. So the first part here, number 20, you had to explain why they used a certain symbol, and you had to explain what each of these things was representing in our inequality. All right, and a lot of that information was found right up here. Let's keep going. In the second part of this problem, you again have that inequality. They wanted you to figure out, can this many kids ride the ride if 4 adults are already in the log? So what I did was I plugged in a 4 here for the number of adults, and that's 600 pounds. The log itself is 200 pounds, so far there's 800 pounds accounted for. And if it needs to be less than or equal to 1,500, that means that they still have room for 700 more pounds. Okay, that's what I kind of showed up here. They still have room for 700 more pounds, which according to their formula, that would be a maximum of 7 kids. Okay, so if I go down here and look at these number of kids, I put them here as well for each group, that means the ones that had up to 7 people were okay. Okay, those were legitimate groupings that could be allowed. But if they had more than that, 8 or 9 kids, now we're over the weight limit. Okay, those were the ones that we would say, nope, not allowed. You also got to wonder about space concerns at that point, okay? But that would not be allowed. So that one was a no, and group 5 was a no. So that's how this one went. That brings this to a close. Your next step is to do your test corrections now, all right? So you need to go back and now correct what you missed and show that you've kind of understood your mistakes and that you're able to learn from that.